Okay, I thought I'd start doing the problem that we got stuck on in class today, page 435, number 19, when you're given the two focal points of an ellipse and you're given the sum of the focal radii. And it says find the equation of the ellipse. And the directions were to use the definition of what an ellipse is. And if you look up the definition of an ellipse, you find out that it is the distance between from these 2 points to the ellipse is a constant, and that constant is 2a, which is the sum of the focal radii. So, how do I find the equation for that? First thing I like to do is plot the points to get a look at what we've got here. So F1 is 1, 1. So over 1, up 1. There's that point. F2, minus 1, minus 1. So we already noticed that this is a little bit different than all the ellipses we've studied to this point because the major axis is on the diagonal that goes right through 0, 0 there. And the major axis that this ellipse is on is like that. So it's not a very easy way to figure out just by counting. Often we would just count on the major axis and the minor axis the numbers to sketch out our ellipse. So we have a little bit more work to do here. And since if I take some distance from this point plus this point, let's label these F1, F2, and whatever that is to the ellipse is some constant. And in this case, it's a constant equal to 3. So let's use the distance formula. I don't really know where the ellipse is at this point. So it's some random point. So I'm just going to put a random point up here and call its ordered pair x, y, because I don't know what the ordered pair is yet. But I do know the ordered pairs of these two. So let's put our other point up here, x, y. Now, if I use the definition of an ellipse, the distance from F1 to that point plus F2 to that point should equal 3, which is the sum of the focal radii. So I have the distance formula up here. So let's set that up. So that means I have to do the distance from here to here. So let's call this x1, y1. So we'll call this x2, y2. So I have to do x2 minus 1, x2 minus 1 squared plus y2 minus 1 squared, and I have the square root of that, plus the square root. Now we're going to call this my x1, y1. We'll use that point again. So I'll do x2 minus negative 1 squared plus y2 minus negative 1 squared. And the sum of these two distances has to equal 3. Now, all I have to do is solve that equation. I hope you notice that this double negative here becomes a plus. Now, if I want to solve this, I could square both sides. I could square this whole side and this whole side. Problem with that is I have two radicals here, and even though squaring this so-called binomial, I'll still end up with a radical on the inside. So I'm going to end up squaring 2 times, but before I do that, I want to move this one to that side. So I'm going to rewrite this. So I have square root x squared minus 1, x2 minus 1 squared plus y2 minus 1 squared equals 3 minus the square root of x2 plus 1, we'll change that now, that double negative, plus y2 plus 1 squared. Now since both of these have x2's and y2's, I think it's easier not to use the subscripts, so the x's are the same and the y's are the same. Now all I have to do is square both sides. So let's do that. This side is easy. This one is a binomial, so it's a little bit trickier. On this side, when I square something in a square root, I end up with x minus 1 squared plus y minus 1 squared equals, now when I square a binomial, square the first term, 9. It's a minus, so I have a minus here. This times 2, so 6 times the square root of x plus 1 squared plus y plus 1 squared plus this last term squared, so it's going to be x plus 1 squared plus y plus 1 squared. Now, a lot of work here. I think that you could do this. Square this. Remember, it's a binomial squared, so it's going to be 3 parts. Square this. Leave that alone. Leave that alone. Square this. Square this. Then move everything onto this side of the equation except for that radical, or except for the minus 6 in that radical. Once you do that and combine like terms, you have to square things again. And I want you to try this. And if you can do this and get the correct answer, put it in a sealed envelope, put it in my mailbox, and I will give some extra credit points to the first 3 people that get it in my mailbox in a sealed envelope. Now, the problem is, how am I going to know whose envelope is first? You need to get a staff member to sign the envelope and put the time that you put it in my mailbox. So, the contest begins. All right? So, contest. Right? I need the solution, the work in a sealed envelope. Third thing, staff member has to sign it. Staff, sign, and date. And you can get extra credit points if you're right. So, good luck. You can do this. I solved it. It works. It comes out to the answer in the book. You know what the answer is, but I need to see your whole solution. Good luck. You can do this. So just to clarify, you need the solution, you need the work to verify the solution, you need a staff member to sign, date, and put the time, okay? In case we have a couple people with the same date. So time, and the first 3 people with a solution, signed, dated, and timed, sealed envelope, my mailbox, will get extra credit points. The contest begins. Yay!